Hello guys, in this video tutorial we are going to discuss AMF redirection. Suppose like we have UE. So UE will be providing requested NSSI and it could be based on allowed NSSI, some default configured NSSI or like NSSI that is used for established period connection. And like here we have some steps for that particular redirection. Okay, so in step 1, like the UE sends its registration request to the cell tower or engine, and it includes the requested NSSI, like its list of slices, you can say. The engine looks at the request, applies its local routing policy, and then select the AMF. So here engine forwards the next registration request to the initial AMF. Here like the initial AMF is just a temporary landing zone, you can say. Now here initial AMF receives the request but cannot act on it, so it must verify the user's contract and the network topology. So there comes the step 3, which is this kind of subscription check. Now the initial AMF queries UDM. UDM replies with the subscribed and says NSSI, and like it is like typically saying like yes, this user pays for the enterprise slice, like they are requesting like that. Now in the step 4 there will be kind of topology check. Okay, so now the initial AMF queries this like slice orchestrator, you can say the NSSF. This is where like the redirection is kind of triggered. The NSSF analyze the request and it realized that like while the user is authorized, the initial AMF is not equipped or designated to serve that particular slice. Okay, so the NSSF generates that allowed NSSI and explicitly and kind of like select you can say the target AMF set, you can say, or you can say a list of AMF as well, and that is kind of authorized to handle that particular traffic. And like in legacy network, like this kind of scenarios were not used. So in legacy network, like in incorrect routing might attempt result in some dropped call or kind of force attach, reattach, you can say. But 5G handles this seamlessly in the background, you can say. Now in the step 5, the initial AMF accept that it is not the right node for that particular job. So it encapsulates the original NAS message registration request along with all the slicing information it like got from the NSSF and routes it directly across the core to the target AMF. Now in the step 6, now the new AMF like is now designated as a serving AMF, receives the forwarded payload, you can say, and it now has the user request, the authorized slice ID, and also it has like the mandate to take over for that particular session. Now in step 7, the serving AMF completes the authentication and registration process. It sends registration response back to the UE and providing the finalized allowed NSSI, and also it updates the NGDN like ensuring that any subs or any like further you can say traffic from this UE is routed directly to the new serving AMF, and it can bypass the initial AMF moving forward. So like while AMF redirection, it is kind of brilliant from architectural point of view, but like it is like expensive and kind of introduce some signaling latency, like okay during the initial attach. And if you are like designing the enterprise deployment and notice you are having some high volume of AMF redirection in your signaling traces, it is kind of a massive red flag for your solution. Okay, so it usually means like your engine like lacks the proper AMF selection logic, and you can see updated neighbor routing tables to map the requested NSSI to the correct AMF IP pools. So you need to look on the ng and configuration for that. So that's it from this slide. I will see you in the next slide.